Hello again, everybody. It's another day here in California where we are at home due to the lockdown or the shelter in place order from the state. And I figured what better thing to do today than talk probability. And today we're actually going to talk about the probability of independent events, say like rolling a die or flipping a coin, and how one of those outcomes, say a 6, does not affect the outcome of another roll or a flip of a coin. So let's get going.
All right, so we're going to make a tree diagram for the outcomes of two coins being flipped. So the first coin could be either heads or tails, and then the second coin, let's say the first coin rolls heads, then the second coin could also be either heads or tails. And then if the first coin goes tails, then the other coin could be either heads or tails. So in terms of outcomes, we could have either heads, we could also have heads, tails, or tails, heads, or tails, tails. And since we're assuming these coin flips to be fair and perfectly even in terms of 1/2 chance of heads or tails, each of those four outcomes is 1/4. All right, now let's look at a tree diagram, except this time we're going to look at the outcomes of flipping a coin and rolling a fair six-sided die. So just like in the other tree diagram, we're going to start with our outcomes for our coin, which could be either heads or tails. And then from each of those outcomes, our die could give us 1, 2, 3, 4, 5, or 6, with an equal probability for all those outcomes of 1, 2, 3, 4, 5, 6. And so as you can kind of start putting together, we're going to have 12 possible outcomes, which we get from 2 outcomes for the coin and 6 outcomes for the die. And then we can follow the branches of our tree diagram to get whatever outcomes we want.
Okay, so while that that arts and crafts version of a tree diagram can be useful, let's generalize it, and this is the way I think most people will end up tackling a tree diagram. So this is for 2 coins, and it's heads or tails on either coin. So let's say we have, so here's the first coin. First coin starts here, here's this little node, and that first coin could have either a head or a tails. And in this case, it's each, the probability of a head or a tail is each 1/2. And then after that first coin flips heads, you could either have another head on the second coin or a tails on that second coin. And each of those would be 1/2 as well. And then here, this tails on that first coin could result in either a heads on the second coin or a tails on that second coin. Again, each of those is a 1/2. So let's look at how many outcomes we could possibly have. Well, here we have heads, 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 tails, and I'm doing this by going heads, 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 tails, or tails, heads, or tails, tails. So there are 4 outcomes, and the way we could figure out the probability is, well, this is 1/4, heads, 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 tails, that's a 4th, because there are 4 equal possibilities. Here's tails, heads, that's also a 4th, tails, tails, that's also a 4th. So in other words, all these there's a 1/4 chance, or 1 out of 4, of getting either of these. So if we wanted to say, what's the probability of, let's say, at least one head, so in other words, heads, tails, or heads, heads, or run out of room. Tails, heads. Because this would be at least one heads. Well, that would be 1/4 plus 1/4 plus 1/4, which is equal to 3 out of 4. And you can see it here because there's a quarter, there's a quarter, there's a quarter. There you go. And the complement of this would be basically the probability of no heads at all. So probability of no heads. You could do it a few ways. You could do 1 minus the 3/4. Or you could look at what we have here in our tree diagram and go, oh, this is the only outcome that doesn't have a head, so it's a quarter. There you go, so that's a tree diagram.
So now we're going to look at an area model for the coin and die roll. And it should look familiar to us. It looks kind of like multiplying binomials.
1/2 for the tails. Cut that up. And then for the die, we could either have 1 out of 6 for the 1, a 1 out of 6 for the 2, a 1 out of 6 for the 3, 1 out of 6 for the 4, 1 out of 6 for the 5, and 1 out of 6 for the 6. That's right. There you go. So then we're going to cut this up
into little sandwiches.
That's right.
Baby sandwiches.
There you go. So here, what we're going to do then is to find the probability of, say, a heads and a 1 is we multiply all this together. We get, what's the area of this little rectangle? Well, it's 1/2 times a 6th. 1/2 times 1/6. I'm just realizing there's not a lot of space in here, but this ends up being 1/12 because you multiply the numerators, multiply the denominators. And in fact, all of these end up being 1/12. So here, this whole area ends up being 1 because here's 1/2 and 1/2, which is 1. All these sixths added together will be equal to 1, so it's 1 times 1. So this whole area of this rectangle is 1. But each of these little sections in here are the probability of rolling, say, a 2 and then getting, say, tails. It's a 12th. So we'd say the probability of 2 and a tails is, well, the probability of 2 is 1/2. Probability of 2 is a 1/6, excuse me, and then the probability of a tails is 1/2, which is 1/12.
All right, so to generalize people, the multiplication rule for independent events where the outcomes do not affect the outcome of another event is the probability of E and F is equal to the probability of E and F. Have fun, people.